Alright, in this video I am going to go through the multiple choice practice problems. There are 10 of them. Alright, starting off with number 1. We have the graph of f of x shown in this picture, and we are trying to find the correct order of f prime. Well, we know that f prime is going to give me my derivative, so we're going to just look at a couple pieces here. F prime of A, f prime of B, and then finally f prime of C. So the derivatives are the slopes, and as I look here, the slopes of f of x at A are negative, so we know that these ones are going to be negative. At f prime of B, well, that's a minimum in the graph, so my slope there is 0. And f prime of C, the function is increasing, so that slope there is positive. So as I put these in order, f prime of A is the lowest, so that means these two are out. F prime of B is less than f prime of C, since that one is a positive value. So my first answer is going to be D. Next one, we want to go ahead and find the absolute maximum minimums on the interval from -2 to 5. So the first thing we're going to do whenever we see absolute max and mins, we're always going to think that that is the first derivative set equal to 0. That's going to give me my critical numbers, and that's the only spot where we could potentially have relative maximums and minimums. So I'm going to start by taking the derivative. Derivative of 10 is 0. Derivative of negative 6x squared is going to be negative 12x. Setting it equal to 0 so that we have the critical number of 0. Now, these are asking for absolutes, not relatives. So remember, on every closed interval, as long as the function is continuous, we can guarantee to have a absolute minimum and an absolute maximum. It could be at the endpoints, or it could be at that critical number. So we're going to take my endpoints, -2 and 5, and the critical numbers that fall in that interval, which is 0 in this case. And we're going to take those three x values and plug them into g of x. Actually, let's write g of x here. So 10 minus 6 times -2 squared is going to be that first number. That's going to be 10 minus 6 times 4 is 24, so 10 minus 24 is going to be -14. Plugging in 0, that's going to be 10 minus 0, which is 10. And then finally 5. 5 is going to be 10 minus 6 times 5 squared. 5 squared is 25 times 6 is 150. So 10 minus 150 is going to give me -140. So my absolute maximum is going to happen right here. My highest y value at 0. And that value is 10. Oh, so that gives me the only option that I have then is B, because the other ones don't have the correct values. But that also gives me then the minimum at 5 is -140. All right, now we're looking for a relative minimum. Still talking about that first derivative of x, and we're setting it equal to 0. But now we're looking for the change here. We want it to go from a minimum. We want it to go from negative to positive. So the first thing we're going to do is we're going to take the derivative. That's going to give me 6x squared minus 6x minus 12. And set that derivative equal to 0. I'm going to factor out a 6 right away to give me x squared minus x minus 2. That's nice and factorable. So x minus 2, x plus 1. So I know that I have critical values to put onto my number line. So I'm going to label as f prime as negative 1 and 2. I'm going to start with the easiest test point that I can. I'm going to plug in 0. That's between negative 1 and 2. And as I plug in 0, remember, we don't care what the actual number is. We just care about the sign. So 0 plugged into the factored is going to be 6. 0 minus 2 is going to be negative. 0 plus 1 is positive. So 6 times a negative times a positive is going to give me negative values between negative 1 and 2. Plugging in something less than negative 1, let's pick like negative 2 here. So negative 2 minus 2 back into my first derivative is going to give me negative 4. Negative 2 plus 1 is also negative. So negative times a negative is going to be positive. And then as I multiply by 6, it's going to stay positive. All right, and then finally something greater than 2. So I'm going to pick 3. 3 minus 2 in my derivative is positive. And 3 plus 1 is also positive. So positive times 6, positive. Now we're looking for the change from negative to positive. So we're looking, and I just kind of covered it up here. X value of that relative minimum. So from negative to positive, that X value is 2, which should be an answer of C. All right, in this one, all right, again, I see relative mins and maxes in the question for all three of these options. So I'm looking at f prime of x set equal to 0. What's nice is they already gave me my derivative here. So we're going to set each part equal to 0 so that I can have my critical values at 2, 3, and 4. And then we're going to plug in some test points. Again, I don't care what the values are. I just care about what the signs are. So I'm going to start with the easy one, in my opinion, is going to be 0, something less than 2. So 0 plugged into this derivative, 0 minus 2 is negative. 0 minus 3 is squared, is that negative squared, which is going to make it positive. And 0 minus 4 is negative, and then we cube it, it's still negative. So I had a negative times a positive, that's in the middle. So this is going to be positive for the whole value, everything less than 2. All right, something between 2 and 3, I'm going to plug in 2.5. 2.5 minus 2 is positive. Anything squared is always going to stay positive anyways, no matter what it is. So positive times positive, negative 2 minus 4 is negative, and then I cube it, it's going to stay negative. So the whole thing, positive times negative, is negative. Then from 3.5, as we look at 3.5, 3.5 minus 2 is positive. Anything squared is positive, and 3.5 minus 4 is still negative, and I cube it, it's going to stay negative. Last one, something bigger than 4. I'm going to pick 5. 5 minus 2 is positive. Anything squared is positive. And 5 minus 4 is positive cubed. So positive times positive times positive. Going from positive to negative, this grouping right here, this value at 2 is going to give me a minimum. Sorry, I mixed that up. I drew the picture wrong. Positive to negative. Positive to negative. There we go. That gives me an x value at 2. That's max. 3 is nothing since it's going from negative to negative. And then at 4, negative to positive. Negative to positive, that's going to be my minimum. So I do not have a relative minimum at 3. I do have a relative maximum at 2. And I have a relative minimum at 4, so that's one's wrong. So the only option I have here is 1. All right, next one in the figure below shows the graph of f prime, the derivative of the function of f, on the interval from -7 to 7. All right, if there are 4 zeros on the derivative, that means it's touching the x-axis 4 different times. How many relative maxima does it have? So we're looking for relative maximum. If we have a maximum, it needs to go from positive to negative. And since this is the derivative graph, we would be looking for it to go above the x-axis to below the x-axis. So what I'm going to do is I'm going to take my highlighter and I'm going to start by highlighting everything above the x-axis. And then I'm going to go, and in a different color, I'm going to highlight everything below the x-axis. And I'm looking for where it goes from above down to below. Above to below, that only happens one time. That is right here. And so that's going to end up being A for my answer. All right, number 6 is asking for when the function is concave up. So you got to think about concavity. That is my second derivative. And where I'm going concave up, I'm looking for my second derivative greater than 0. So start by taking first derivative. After we have the first derivative, then we're going to go right ahead and take the second derivative. And we got to get my critical numbers, so I'm going to set it equal to 0. Solve. And my only critical value, the only spot where I could potentially have a point of inflection is at 2. Well, now that I know that that's my only possible for my point of inflection, these are going to be gone. And if I take 0, something less than 2, and plug it in to the second derivative, I get -12. And if I plug in something a bit greater than 2, something like 3, 3 times 6 is 18 minus 12. That's going to be positive. So concave up, I'm looking for where the second derivative is greater than 0. So that's where that's positive. So that's going to end up being A. X's are greater than 2. All right, next one, number 7. We are looking for intervals of increasing. Intervals of increasing, I'm looking at f prime of x is greater than 0. So I'm going to start off right away taking my derivative. That's going to be 300 minus 3x squared. I can factor out a 3 to get 100 minus x squared. And then it's set equal to 0, so 3 is never going to equal 0, but I can set that inside piece equal to 0. So that I get x squared equals 100, so that x is equal to plus or minus 10. That means on my first derivative number line, I'm going to put -10 and 10. Now, I always like to start with 0, so between -10 and 10, that would be 0, would be a nice value to put there. Plugging it into my factored one, factored first derivative, 100 minus 0 is still going to be 100. So 3 times 100 is positive. Then let's plug in something less than 10. So negative 11. Negative 11 squared is going to be 121. So 100 minus 121 is negative, times 3 is still negative. Now if I put in positive 11, since I'm squaring it, it's going to follow the same idea and pattern. So that one will also be negative for everything greater than 10. So I know that this is increasing from negative 10 to 10. All right, in this one, we are looking for when we can satisfy the conclusion of the mean value theorem. So I'm going to go right ahead and I'm going to draw on the slope of my secant line. And now we're just going to look every time as we trace, right, this, when does it have the parallel slope to the slope of the secant line. So as you trace the function, when will that slope of that tangent line be the exact same thing as the slope of the secant line? And that happens 4 times. Really, as it starts to change concavity is where those pieces happen at those different points. So this happens 4 different times. Okay, go on to number 9. All right, there's a lot going on here. The first one is the continuous function of f is defined on the interval from negative 3 to 6, consists of 2 quarter circles, 2 line segments, as shown in the figure above. Which of the following statements must be true? So the average rate of change from negative 3 to 6 is negative 1/9. So the average rate of change is going to be the slope of the secant line. That's right here. So I'm going to go negative 1 minus 0 over 6 minus a negative 3. Which is going to leave me with an answer of negative 1 over 9. So this is true. If I know 1 is true, then I know C is not an option. Then there is a point C on the interval from negative 3 to 6 for which the derivative is equal to the average rate of change. Now, this is asking for MVT. And for MVT to be true, the function needs to be continuous on the interval. And it is definitely continuous on the whole interval. If we can trace this entire thing, and as I trace that entire thing, I don't have to pick up my pencil at all. And that is true. There's no holes, no vertical asymptotes, no jumps in the graph. But the thing about MVT is that it has to be continuous, but it also has to be differentiable, which when we look at differentiable, we mean that there can be no vertical tangents, but there also can't be any cusp. And so there's a cusp right here at 2. So this one is going to be false. All right, if h is the function given by h of x equals f of 1/2 x, then at h prime of 6 is negative 1/2. Okay, so they made a new function for us. It's h. It includes f, but not f of x. It's f of 1/2 x. So I'm going to take the derivative of h, and that's going to be chain rule. derivative of the outside, which is derivative of f, copy and paste the inside, times the derivative of the inside, which is going to be 1/2. Now we're finding h prime of 6. So I'm going to fill in 6, which is going to be f prime of 1/2 times 6, which is going to be f prime of 3, times 1/2. Well, f prime of 3 is going to be right here. I want the prime of this line, so I want the slope of this line. Slope of that line is going to be -1 minus 3 over 6 minus 2 to give me -4 over 4, or -1. So f prime of 3 is -1 times the 1/2 from our chain rule, which is going to make it -1/2, which makes this statement true. I know 2 is false, so that's going to eliminate those two options, leaving me with my only possible answer anyways, but the two true answers, 1 and 3. All right, last multiple choice question that we have is number 10. Again, there's a little bit of reading here, so we know the function is continuous on the closed interval. So we know continuous. From from 2 to 5, I'm sorry. F of 2 is 17, and f of 5 is 17. Okay, so I can see that the y values are the same. Which of the following additional conditions guarantees that there's a number c on the interval from 2 to 5 such that f prime of c equals 0? Okay, so what this is asking for is Rolle's theorem. If we know the y values are the same, we know somewhere along the way we're going to have a slope of 0. Okay, if I would graph this out, 217 and 517, no matter how I draw in that inside graph of f, all right, at some point, I'm guaranteed to have slopes of 0. However, two things need to be true. The first is that it needs to be continuous, and we have that. The second piece, in order for us to use Rolle's, we have to make sure that it is differentiable. Because if this graph is not differentiable, let's say it has a cusp on it, now I can have two y values are the same, but I don't ever have a slope of 0 because that cusp is not going to have a slope. It's not differentiable, and so I don't have Rolle's theorem able to work. So for 10, your answer is C. The function also needs to be differentiable on that open interval from 2 to 5.